Welcome to the brand new section of this course, titled Dimensionality Reduction. In this section we will look at topics such as reducing dimensionality with PCA, using decomposition to classify with dictionary learning, dimensionality reduction with manifolds, testing methods to reduce dimensionality with pipelines. Now let's move on to the video, reducing dimensionality with PCA. In this video we will cover several decomposition methods available other than PCA, which is a member of the decomposition module of scikit-learn. Let's use the iris dataset, but it's better if you use your own data. Import datasets from sklearn, then import pyplots for visualization. Import numpy and pandas for scientific computing and data structuring and analysis. Then load an object of iris dataset. Load the data as iris X and target as Y. Now import the decomposition module. Instantiate a default PCA object. Next, let's check the PCA properties using the command PCA. Compared to other objects in scikit-learn, the PCA object takes relatively few arguments. Now that the PCA object has been created, simply transform the data by calling the fit_transform method with iris X as the argument. Let's see the array values. This is the array list you'll get. Now that the PCA object has been fitted, we can check explained variance ratio with the help of this command. You will get the output like this. Let's see it's working. PCA has a general mathematical definition and a specific use case in data analysis. PCA finds the set of orthogonal directions that represent the original data matrix. Generally, PCA works by mapping the original dataset into a new space where each of the new column vectors of the matrix are orthogonal. From a data analysis perspective, PCA transforms the covariance matrix of the data into column vectors that can explain certain percentages of the variance. For example, with the iris dataset, 92.5% of the variance of the overall dataset can be explained by the first component. This is extremely useful because dimensionality is problematic in data analysis. Quite often, algorithms applied to high-dimensional datasets will overfit on the initial training, and thus lose generality to the test set. Create a PCA class with two components. This will fit and transform the data with iris X as the argument. This command will find the shape or dimension of iris X prime, and the shape will be 150 and 2. This shows that our data matrix is now 150 by 2, instead of 150 by 4. The separability of the classes remains even after reducing the dimensionality by 2. Let's see the variance represented by the two components that are remaining. Run this command, and you will get output similar to the one shown on the screen. Let's visualize what PCA has done. Plot the first two dimensions of the iris dataset with before and after pictures of the PCA transformation. For that, first plot the figure. Add a subplot to it. Visualize the first two columns of iris X. Set the title as before PCA. Again, add the second subplot to figure. Visualize the first two columns of iris X prime. Set the title as after PCA. Now let's visualize it using plot.show command, and here is the plot. The PCA object can also be created with the amount of explained variance in mind from the start. Clear this. If we want to be able to explain at least 98% of the variance, then we need to create PCA object. After that, fit and transform it. Let's see the variance represented by the two components that are remaining. This is the output you will get. It's time to scale PCA, so import preprocessing. This command will standardize a dataset and scale with argument iris X. Instantiate a default PCA object with two components. Then fit and transform the scaled data. Now we will visualize the content. For that, first instantiate the figure. Add a subplot to it. Visualize the first two columns of iris X prime using scatterplot. Set the title as before regular PCA. Again, add the second subplot. Visualize the first two columns of iris X scaled using scatterplot. Set the title as scaling followed by PCA. Use plot.show command to visualize. Nice, this is output that we were waiting for. So we end our video at this junction.